I want to split the data set up into training and testing. So I'm going to go x underscore train is equal to capital X. I'm just going to do it by hand. From 0 to 60,000, comma, all of my columns. Okay, so I'm going to just copy this down 4 times. So I have the pattern. I have x train, and then I have x test, and that's from 60,000 to the end. So I'm just going to go 60,000 colon. And then I have y train, capital Y, capital Y, capital X, y train, and y test. And that's going to be from y 0 to 60 and from y 60 to the end. Y train doesn't like, oh wait, yeah, sorry. Y only has 1 column, so I don't need that. Okay. So then I've got my x train, my x test, my y train, and my y test. So I've got it split up now. So we want to train a stochastic gradient descent classifier. So first we want to extract a subset for our kind of 5 detector. And that's going to be y underscore train underscore 5 is equal to y underscore train equals to 5. Whoop. Y underscore test underscore 5 is equal to y underscore test equals to 5. All right, so now I'll highlight that, hit F9. Ooh, t-test, that doesn't like. That's a very different class. Okay. Y train test and y test 5. So all of these are just 8 to the 5, 15 to the 5, 23 to the 5, 52 to the 5, 53 to the 5. So that's what those give us. Okay. So now we want to build and train the classifier. And again, this is just going to use stochastic gradient descent, and it's slowly going to update the slope of that line until we get one that tries to maximize the distance, right? Minimizes the error. So we've got SGD CLF, stochastic gradient descent classifier, is equal to sk.linear underscore model dot SGD CLASSIFIER open and close brackets. And that should create a classifier. No options. Oh, LINEAR. Okay, so from sklearn, import linear model. And now I should be able to build that model. Beautiful. Now I just want to train that model. So SGD CLF.FIT X underscore train. That gives me all of my X training data. And now I need a tag to train it on. So I have to train, it's binary, so it's either true or false. So I have to train it on just 5. So I'm going to go y underscore train underscore 5, hit F9, and now I am training a classifier model that will allow me to detect 5s in the MINT data set. All right, so that has now been trained. And let's go ahead and plot. So I'm going to come up here and I'm going to copy this code I had for test digits. I'm going to go plot test digits. And let's go ahead and play around with a few digits. So let's say 35 was okay, right? So let's go 35. Again, let's plot 35 so we know what we're looking at. So a 5-digit, number 35. So that one looks pretty good. Now, can we use our model to predict if this is a 5? That'd be pretty cool, right? We built a machine learning model. Let's see if we can do that. So I'm going to go, I just wanted to print print sgd underscore clf dot predict. Test underscore digit. I need an extra set of parentheses there. True. It predicted that as a true case. Okay, so let's go ahead and say, what about 2? I have no idea what 2 is. I'm just picking my favorite number there. 2 looks to be a 4. I would classify that as a 4, and my machine learning model classified it as false. Right? Has anyone ever seen the show Silicon Valley? No? Okay. Well, then that joke won't last. But it's a show about people in a startup company, and the guy makes a classifier for a hot dog, and they're very impressed because he can use his phone to take a picture of a hot dog, right? And they go, "Oh wow, it worked. We're gonna be rich." Then he takes a picture of like a pizza or something, and it just says "not hot dog," because that's what a binary classifier does, right? It's only trained to classify hot dog versus not hot dog, or 5 versus not 5. So let's take a look at some of the other 5s that were kind of problematic, right? Let's see if it can pick them out. So the next 5 we had on our problematic list of problematic 5s was 0. No. Yes. 0. So before we look at it, it says false. My classifier says this is not a 5. So let's go ahead and look at 5. All right, my classifier says not 5. Well, who are we to argue with machines, right? What was the next one we had? 100. I don't think it'll classify it. Anyone think it'll classify it? And anyone want to take that bet? True. Fascinating. All right, so it says this is not a 5, and it says that is a 5. What?
Maybe it's a 2. Figure 4.
Figure 4. Oh, maybe it's 2. Well, I mean, so the NIMS data set tells us it's a 5, right? What does that mean? I don't know, you know, but that is labeled as a 5. So we just take that to be the truth. So if I look at this, and I'm greatly oversimplifying what a machine learning model can do, maybe it's seeing that this curvature here is pretty characteristic of a 5, right? That square line and pixels in that place are pretty characteristic of a 5. But this, once you get pixels out here, that's pretty characteristic of a 3, right? And so maybe it's thinking that this is more of a 3 and that's more of a 5, although it actually hasn't been trained on 3s at all. So it's not really something that we can state, but it is something to think about.